Okay. I was trying to increase the size of this so you can see it better, but I'm obviously not smart enough to do that in Google Chrome. Um, an insurance company crashed 4 cars of the same model at 5 miles per hour. The cost of repairs for each of the 4 crashes was 419, 450, 466, and 203. Compute the mean, median, and mode cost of repair. Go to my calculator. I'm going to press my stat, do an enter on edit. If you have numbers already there, you can just press delete, and it'll delete whichever one's highlighted. Just make sure L1, L2, and L2 aren't highlighted, otherwise you'll delete the list. I'm going to left arrow over. There is quicker ways to clean out this list, but I may show it in this video. Okay, so we got L1 and L2 cleaned out. We're going to put our numbers in L1. We've got 419, so 419, enter. 450, so 450, enter. 466, enter. And 203, enter. Now they're wanting us to compute the mean, so if I exit out now, do second mode exits you out of anything, and I press stat, and I right arrow to calc, and one of our stats is already selected, or highlighted, so I'll do enter on it, and I'll do enter again. The X bar is our mean, so 384.5. So I'll come here, 384.5, round to the nearest cent. Okay. Compute the median. I'm going to come down over here, and I'll down arrow until I get to the second page, and you see MED says 434.5. So 434.5. And compute the mode. Now mode is the number that occurs the most often. It has to at least occur twice. I see you got 419, 450, 466, 203. None of them repeat, so the mode does not exist. So I choose that. And then I'll click next question. Okay, Benjamin owns a small internet business. Besides himself, he employs 9 other people. The salaries earned by the employees are given below in thousands of dollars. Benjamin's salary is largest, of course. Complete parts A through D. Okay, so I'm going to go press clear here to clear that out. I'll go into stat, enter on edit. Now let me show you the quick way to clear out the list. You have to be careful with this. I'm going to up arrow and highlight L1, and I'll press my clear key and enter. You want to make sure you don't press delete. Let me show you what happens if you press delete. If I up arrow and I have L1 highlighted and I press delete, I just deleted L1, which can mess you up. So if you come into this and you're looking and say, well, I don't have L1. To get it back, see where my cursor is down here? I'm going to up arrow one time, put my flashing cursor or put my highlighting on L2, and then I'll do second delete. And that'll insert a list. Now to put L1 back, you see above the 1 button, it says L1. So I do second 1 and push enter. Now one of our stats by default assumes L1. So that can mess you up if you delete L1. Okay, we got 20, enter, 35, enter, 45, enter, 50, enter. I'm not very good at typing in numbers, so I make no guarantee I won't get a problem wrong on this test. 50, enter, 50, enter, but I think you get the idea, if nothing else, of how to do these. 2 55s, so 55, enter, 55, enter, 60 and 80. So 60, enter, 80, enter. Okay, so I'm going to exit out, do second mode. Now it asks us the mean and median in mode. So we're going to do one of our stats again. So press stat, right arrow to calc, enter on one of our stats, and enter again. So our mean is X bar, which is 50. So I'll put 50 here. The median, if I down arrow till I see the MED, it says 50. It's interesting. Now the mode. The mode is the number that occurs the most often, and I think 50 occurred 3 times. 55 occurred twice, so our mode would be 50, since it occurs 3 times. It's the one that occurs the most often, but it has to be greater than 1. So it has to at least occur twice. Okay, business has been good. As a result, Benjamin has a total of $25,000 in bonus to distribute to his employees. One option is to give each employee $2,500. Add the bonuses under this plan to the original salaries to create a new data set. Recalculate the mean, median, mode. How do they compare to the originals? Okay, we're adding $2,500. The original one is in thousands of dollars, so like this 35 here, thousands of dollars. That'd be 35,000. Which means we're going to add 2.5 to the original data. Hopefully I'm reading that right. Stat, and I'll go over to edit. Go into edit, and now I'm going to right arrow over to L2, and I'm going to up arrow and highlight L2. Now we can actually type a formula in here. So I can do second 1, and you see L1 appears down here, plus, and we're going to add 2,500 to each one of them, but we have to do it in thousands, so it'll be 2.5. So you should see L1 plus 2.5. Now that only works if you got L2 highlighted up here. If you just got your first entry highlighted, this won't work. And then press enter. And you see that it went through and added 2.5 to each one of those. Now that's in L2. So let's exit out, do a second mode. And I'll press clear to clear that. We're going to do one var stats again. So I'll go to stat, right arrow to calc, do enter on one var stats. And I'm going to do a second 2 to put L2 there. That'll tell it to do one var stats against L2. Enter. Now remember, X bars are mean, which is 52.5. So 52.5. Median, I'm going to down arrow until I see the MED, 52.5. Now if 50 occurred the most here, mode-wise, then if I added 2.5 to everything, then 52.5 will be my new mode that occurs 3 times. Okay. How do the mean, median, mode compare to the originals? Increased by... Yeah, I guess that did increase by 2,500, didn't I? Okay. As a second option, Benjamin can give each employee a bonus 5% of his or her original salary. Add the bonuses under this second plan to the original salaries to create a new data set. Recalculate the mean, median, mode. So 5% of the original salary. Okay. So I'm going to go to stat, and I'll do enter on edit. I'm going to go over to L3. So I right arrow over here, and I'm going to up arrow and highlight L3. And now I'm going to do second 1. So I'm going to add my original salary plus, and then I'll do second 1 times, and 5% of the original salary. So I'll multiply that times 0.05. So L1 times 0.05 will figure 5% of the original salary, and then I'm adding it to the original salary. So that's what that formula says. And we'll press enter. Okay, so that's our new values. Now I'll do a second mode, and I'll do a clear to clear out the old one. I'm going to do one var stats again against L3. So I'll do stat, right arrow to calc, enter on one var stats, second 3, and press enter. That's interesting. Our mean is still 52.5. So down here, put in 52.5. Now our median, I'm going to down arrow, wonder if it's 52.5. Yep, 52. Did I do against L3? Let me just double check myself. I've been 6, so I don't guarantee anything. Okay, calc, enter on one var stats, second 3 for L3, enter, yeah, 52.5. Okay. Median is 52.5. Mode. I don't know. Let me do a stat and do enter on edit. And let me go over to L3. Oops. Looks like 52.5 occurs 3 times. So 52.5 must be our new mode. Excuse me. Okay, how did the mean increase by, all the measures increased by 5%. The mean increased by 20, but the mean and mode did not change. Originally, I think they were all 50, yeah? This is a never-ending problem. The mean increased by, okay, that's not true. Did not change, that's not true. All of them increased by 5%. That might be true. Mean increased by 10%, but the mean and mode did not change. It must be this one. If I went and looked and saw what we increased each individual data entry by 5%, but I bet if you take the 50, yeah, that increased by 5% too. Now, how I know that is okay. So if I had my original 50 and then I took the 50 times 5%, well, this would be 50, and this would give me, I hate decimals. Okay. Ignore the man that can't do his basic math here. Okay, 2.5. That's what I was thinking, but see, and then that gives me my 52.5. So they did increase by 5%. Okay, where are we at now? Part Z of the never-ending problem. Okay, as a third option, Benjamin decides not to give his employees a bonus all. Instead, he keeps $25,000 for himself. Use this plan to create a new data set. Recalculate the mean, median, mode. How do they compare to the originals? What does that mean? Owns a small business. Besides himself, the salaries. Okay, Benjamin's is the largest. Okay, there it is. Benjamin's is the largest, which is the 80 down there. Okay, so he's going to keep the 25,000 for himself, which means we'll replace the 80 with 105. Because this is 80. This is Benjamin's, so I'll say Ben. He originally had 80. Remember, this is in thousands. So he's keeping 25,000 for himself. So in thousands, that would be plus 25. So we want to replace the data entry with 105. Okay. I could put it into a new list, but I might as well just put it in L1. I don't think I'm going to use that again. So I'm going to come down here to the last entry, 80. And I'm going to change that to 105. And then I'll press enter. I'll do a second mode, exit out, and I'll do stat, right arrow to calc, and I'll do enter on one var stats, and enter again. Interesting. X bar is 52.5. So I come over here. This is 52.5. Median, if I down arrow, median is 50. That's different. Some of these other ones, they were all the same. Mode, the one that occurs the most often. Well, that hasn't changed. That'll still be, see how 50 occurred 3 times here? So that'll still be your 50. Okay, how do the mean, median compare to the originals? All 3 measures increased? No. All 3 measures increased? No. Because these two stayed the same. When I say they stayed the same, if we will go back and look at part A, see how we had 50, 50, 50? Okay, the mean increased by 2,500, but the median mode did not change, and the mean did not change. Has to be this one. It's the only option. Okay, let's go to the next question. Question 3. Find the sample variance and standard deviation. Nice short one versus that long one. So let's go to our calculator. And I'm going to put those into the list. So I'll go to stat, do enter on edit. Now I'm going to up arrow and highlight L1. I'll press my clear key and then the enter. Again, don't press your delete. I'll right arrow over to L2. Oops. Up arrow, highlight L2, press clear, enter. And then go over to L3, up arrow, highlight L3, and press clear, enter. There we go. Now we got these numbers, 17, enter, 11, enter, 4, 10, and 12. So 4, enter, 10, enter, 12, enter. Now I'm going to exit out, do second mode, and we're going to go do one of our stats. So I'll press stat, right arrow to calc, do enter on one of our stats, and press enter. Remember, it assumes L1. Okay, now it's asking for sample variance and sample standard deviation. I can go down here and do sample standard deviation first. You see how S is 4.65832588? The SX right here, that's your sample standard deviation. And round to the nearest tenth. Okay, tenth. So that would be 4.7. 4.7. Now for S squared, we want to square the SX. The easiest way is just do vars, choose number 5 for statistics, choose 3 for SX, and then push your X squared button. Now you could just type in an entire number, and that gives us 21.7. Type an integer or a decimal. Type an exact answer. 21.7. Now notice this squares the original sample standard deviation. It doesn't square 4.7. If I did 4.7 squared and press enter, then I get that. You should always go back to your original before you round it when you're finding the variance. Okay, next question. Find the population variance and standard deviation of these numbers. Okay, so I'm going to go and do stat, enter on edit, and I'll up arrow. Actually, let me show another way to clear out that list. Let me do a second mode to exit out. And I go to stat, and you see number 4 says clear list. You can press 4. And then I do second 1. That'll get L1, and press enter. That's the safe way to clear out a list, so you don't accidentally delete it. I'll press stat, enter on edit, and you see L1's cleaned out. Okay, I got 4, 7, 11. So 4 enter, 7 enter, 11 enter. 13 and 15, so 13 enter, and 15 enter. Going to exit out. I'll press clear to clear out the screen. And then I'll do stat, choose calc, and do one var stat. So I'll do enter on that, enter again. Again, assumes L1. Now this O looking thing down here, that's sigma. That sigma x says is equal to 4. So the standard deviation of the population is 4. Which in the population variance is the standard deviation squared, and 4 squared gives you 16. So I don't need to actually use my calculator for that. But if I did, the quick way to do it, if I had a bunch of decimal places here, would be to choose my vars, choose number 5 for statistics, and choose number 4 for sigma. And then push my X squared button and press enter. Okay, next question. Number 5. The weight of an organ in adult males has a bell-shaped distribution with a mean of 350 and a standard deviation of 50 grams. Use the empirical rule to determine the following. Let me see if I can find my picture of this. Because what I draw will not look good. And of course the key is if I can remember what section it's in. I think it's 3.3. Well, maybe I'm lying to you. Group data. That's not it. 3-2. There's our picture. This is out of the textbook. Okay. So we come back to here, and then I want to bring this up, and we're going to draw a bell-shaped curve. Now exactly in the middle here is going to be our mean. Mean at 350. So 350 goes there. Now our standard deviation is 50. So this right here, this is going to be our mean plus 1 standard deviation. Now I'll write these in terms of population values. So we've got mean plus sigma. So we're going to have 350 plus 50, which is going to give us 400. Now this one will be mean minus 1 standard deviation. So this will be 350 minus 50. So this will be 300. And you see how this went from 350 to 400? Once you see that pattern, then you'll have the rest of them. So 350 to 400, then this will be 450, because I'm adding 50 over and over. This one will be 500. Now, the reason why I brought up this, you can see a good picture. This gives you the percent breakdown in each piece. Like this piece here is 34%. So that'd be 34%. It says this piece is 13.5. So this would be 13.5%. This one is 2.35. 2.35. And then this one is 0.15. Now I haven't drawn this very well. I should go teach English. But if you look at this picture, this is what it should look like. Okay, so back over on this side, by symmetry, this is 34, this is going to be 34. Now going in this direction, we're subtracting 350. We go 350 to 300, then this will be 250, and then this will be 200. And 13.5, this will be 13.5. 2.35, this will be 2.35. And then 0.15 will be over here. So again, we start with our mean, and then we keep adding the standard deviation as we go to the right for each of these segments. And we start with the mean, and we subtract standard deviation going to the left. Okay, so that's our setup. Let's go see what the problem's asking for. Part A. About 95% of organs will be between what weights? Now you could sit there and try to figure this out, but it's represented very nicely in the picture here. You see the 95% says within 2 standard deviations. So it's these 4 middle bars. So let me put a little red mark for this is part A. It'll be this bar, this bar, this bar, and this bar. So that's going to go from 250 over to 450. So 250 to 450, because they're asking the range. And you see it starts here and then goes over to here. Okay, so 250 to 450. So 250 to 450. And part B, let me choose a different color. Part B says, what percentage of organ weights, I'm blind. What percentage of organs weigh between 200 and 500? Okay, so 200 to 500. So here's 200. So it starts here and goes to 500. So it goes clear over to here. So we're adding all the percentages in this range right here. Well, you could have 2.35% plus 13.5% plus 34% plus 34% plus 13.5 plus 2.35. I don't know if I can actually add these in my head, but we'll see. That's 68. This is 27. 68 plus 27. And this plus this gives us 4.7. We'll double check myself here in a minute. So that gives me 15, 19, 1, 99.7. Assuming I added correctly. Okay, now you can do a direct addition like that, or you know all of this adds up to 100%. So we're adding everything except for this piece and this piece. Well, 0.15 plus 0.15 gives you 0.3. And if you subtract that from 100, that's a very easy way to get to 99.7. Okay, C. Oops, let me write the answer down. 99.7. 99.7. Now C says, what percentage of organs weigh between 200 and wait a minute, less than 200 and more than 500? Less than 200. So that would be all this over here, and more than 500 would be this over here. Well, that would be your 0.15% plus the 0.15%, which we just said, excuse my writing, 0.3%. Okay, so that's going to be 0.3. Okay, what percentage of organs weigh between 250 and 500? What color should I use? Purple. 250 and 500. Where's 250? Here's 250. 500 would be right here. So we're adding all the bars between these. Okay. D. So this first one is 13.5 plus 34 plus 34 plus 13.5 plus 2.35. So again, we're adding all of the bars between this end and this end. That gives us 27% plus 68% plus 2.35. I probably missed this problem just from basic math error. Okay, 8, 9. I have been sick, so I'll use that as an excuse for any I miss. Either that or the sun was in my eyes. Let's see, 97.35%, assuming I added correctly. There we go. Now let me go to the next question. Okay, following data represents the annual number of days over 100 degrees Fahrenheit in a city from 1905 to 2004, approximating the mean and standard deviation of annual number of days over 100 degrees. Okay, treat the data as a population. Let me start a new page here. We got 0 through 9, 10 through 19, 20 through 29. That was weird. 30 through 39, assuming 40 through 49, and 50 through 59, and 60 through 69. Okay, now we're going to need our midpoints for this, so I'll go ahead and put a column here for that. We'll come back to that though. Let me write down my frequencies. We got 30, 33, 19, 33, 19, 11, 4, 2, and 1. Now for our midpoints. To find the midpoints, you take the lower class limit, which would be this one right here, plus the next one divided by 2. So I'm going to have 0 plus 10 divided by 2. 0 plus 10 is 10. 10 divided by 2 is 5. Now this one would be 10 plus 20 divided by 2. That'd give me 30 divided by 2, which would be 15. But if you remember the class width, yeah, this goes by tens, and this goes by tens. Well, our class width tells us that the midpoints is going to go by tens also. So after you get your first one, then this will be 15, this will be 25, 35, 45, 55, and 65. Now we're going to put the midpoints in L1, and we'll put the frequency in L2. So let's go over to calculator. I'll press my stat button, do enter on edit. I'm going to up arrow and highlight L1 and press clear and press enter. And we got 5, enter, 15, enter, 25, enter, 35, enter, 45, enter, 55, enter, 65, enter. I'm going to right arrow, and I'm going to put my frequency in L2. So 30, enter, 33, enter, 19, enter, 11, enter, 4, enter, 2, enter, and 1, enter. Now they should have the same number of entries if you didn't mess it up. Now do a second mode. Now I'm going to do my 1var stats. So I'll do stat, right arrow to calc, enter on 1var stats, and then I'll do second 1, comma, second 2, and push enter. Now our mean is the X bar, which is 18.6. So I got 18.6. Sigma will be round to 2 decimal places. So that'll be 13.15. There we go. And I'll say next question. Well, here's another one. Gives us this and wants to do the same thing. So let me clear this out and write down my values. 25 through 34. 35 through 44. You notice my class width appears to be 10. We'll see if it's consistent everywhere. 45 through 54. And 55 through 64. And it is consistent. It's adding 10 over and over. So let's find our first midpoint. And then that'll give us all the rest since our class width is 10. We're going to add 25 plus 35. Again, you add the lower class limit here plus the next lower class limit, divide by 2. So we've got 25 plus 35, divide by 2. That gives 60 divided by 2, which is 30. And my class width is 10, which means this must be 40, 50, and 60. Now that's going to go in L1. Our frequency. 26.8, 39.1, 31.9, 25.1. And that's going to go in L2. Okay, so let's come over here. Go into Stat, go into Edit. I'm going to up arrow, highlight L2 and press clear and enter. I'm going to holler at my son to give me a pop because I'm dying here. And up arrow to L1 and press clear, enter. Hey Eric, can we bring me one of my Diet Dr. Peppers out of the refrigerator, please? Oh, I'm gonna thing. Okay. Go give me my pop. Okay, so 30, enter, 40, enter, 50, enter, and 60, enter. And then I'm going to right arrow over to L2, 26.8. Thank you. Yeah, whatever. He brought me my pop. Okay, 39.1. Shouldn't start something where I'm doing a lot of talking without something to sip on. 31.9. Try that again. So you can see I'm not the greatest at data entry, so I don't guarantee I'll get all these right, but okay, 25.1 if I typed everything in correctly. So I'll do a second mode, do a clear to clear that out, and now I'll do my stat, right arrow to calc, choose 1var stats, do second 1, comma, second 2, and press enter. The X bar is going to be our mean. Round to 2 decimal places. So that'd be 44.5. It'd actually be 50, but we dropped trailing zeros. And then our, what are we talking about here? The following data represent number of people aged 25 to 64 years old covered by health insurance, private or government, 2003. Approximate the mean and standard deviation for age. Okay, this is kind of implied that it's population values. Oh, wait a minute. Here's mu and sigma. Okay. If I just open my eyes. And I'll round out 2 decimal places. That'd be 10.45. And actually, SX is blank anyway, so we couldn't use that. Okay, next question. And let me grab a drink before I start this one. This looks like a z-score problem. So let me bring up the formula for z-score. What section is that? I think it's 3.5. No, that's box plots. Never mind. Okay, I lied to you. 3.4. Okay, here's our formula. And this is, come over here, clear this out. Tablet will blow up, so I'm going to bring up another copy. Okay, 1 year, Alex had the lowest ERA of any male pitcher at his school, with an ERA of 3.41. Also, Alice had the lowest. Okay. Males, females. Okay, I'm just trying to read it generally to see what we're talking about. Looks like we have males and females. Okay, now let me read it a little closer. Alex had the lowest ERA with an ERA of 3.41. So Alex X would equal to 3.41. Also, Alice had lowest ERA at the school with an ERA of 3.19. So Alice will be X is equal to 3.19. Okay, for the males, the mean ERA was 4.354. So mean, I'll put mu, not that it matters, was 4.354. 4.354. 4.35. I probably need to make it bigger for just for myself. And the standard deviation was 0.891. So sigma will be 0.891. Now for the females, let's see what the mean and standard deviation was. For the females, mean was 4.767. 4.767. And the standard deviation was 0.684. So 0.684. Okay, find our respective z-scores. So let's do that first. Now our z-score, it's the same formula we're talking about sample values or population. It's x minus your mean over your standard deviation. So for this one, we're going to have x minus mu over sigma. So we're going to have 3.41 minus 4.354 over sigma, which is 0.891. Now for this one, our z-score, we're going to have again x minus mu over sigma. So we're going to have x, which is 3.19, minus mu, which is 4.767, all over sigma, which is 0.684. Now when you type these in the calculator, anytime you have more than a single number or a single variable in top or bottom of your fraction on the calculator, you have to put parentheses on it. So when we plug this in, we want to make sure we put parentheses on the top part on both those. So let's see what that gives us. We'll do a clear to clear that out. I'll do my beginning parentheses, 3.41 minus 4.354 closing parentheses divided by 0.891. 891. And usually you round these to 2 decimal places. So this will be a negative 1.06. Okay, let's see what this one is. So do a beginning parentheses, 3.19 minus 4.767 close parentheses divided by sigma, which was 0.684, and press enter. And we get negative 2.31, around 2 decimal places. Okay, Alex had an ERA. Alex is negative 1.06. 1.06. Alice had negative 2.31. Which student had a better year in comparison with their peers? Even though it looks like Alice's was greater, it's actually less. Because remember, when you get your negatives, then negative 1.06 is greater than negative 2.31. So Alex had a better year because of a higher z-score. Where is it at? Okay, there. Alex had a better year because of a higher z-score. I'll go next question. Number 9. Excuse me. Okay, suppose the data. Okay, with quartiles, IQR. Let me bring up the formulas. Where's it at? Here's IQR. Okay, so we're given a bunch of numbers. Oh, this is great. I wonder if I can type those in without screwing it up. I'll try. First thing we're going to do is we're going to go in and input those numbers into our list. So I'll go to Stat, enter on Edit. I'm going to up arrow, highlight L2, press Clear, enter. Left arrow, up arrow to highlight L1, press Clear, and then enter. And I got 0.22, 0.22, enter. 2.24, 2.24, enter. 3.65, so 3.65, enter. 4.87, 4.87, enter. 0.72, enter. 2.43, 2.43, enter. 3.76, 3.76, enter. 4.98, 4.98. This is the hardest part right here, actually typing them in correctly. 1.09, 2.66, 4.14, 5.14, 1.55, 3.13, 4.28, 5.39, 1.87, 3.51, 4.62, 5.58. Now I'm going to go through and double check my numbers here. I'm at the end of this, when I submit the test, I want to go through and then go see where I screwed up. You know, fix any ones I did wrong, but I don't want to have to retype these numbers in. 5.58, 4.62, 3.51, 1.87. Last row is fine. 5.39, 4.28, 3.13, 1.55, 5.14, 4.14, 2.66, 1.09, 4.98, 3.76, 2.43, 0.72, 4.87, 3.65, 2.24, 0.22. Okay, everything looks correct, so I'll do a second mode, exit out. And they say, what are the quartiles? So let's find those first. So do stat, right arrow to calc, do enter on one of our stats, and enter again. Now I'm going to down arrow. Quartiles are on the second page. You see Q1 is 2.055. 2.055. The median, MED, that's our Q2, so that's 3.58. So 3.58. Q3 is 4.745. 4. What did I say? 745. 745. 4.745. Double check myself here. 2.055, 3.58, 4.745. Okay, our IQR. This is our formula. The IQR is Q3 minus Q1. So Q3 minus Q1. Q3 was 4.745 minus Q1, which is 2.055. 4.745 minus 2.055. Enter. 2.69. 2.69. Okay, upper fence. That's weird. They don't want to know the lower fence? Oh, wait a minute. I'm blind. 2.69. They do want to know the lower fence. Okay, that's a different formula. We come down to here. Now our lower fence is Q1 minus 1.5 times IQR. So for our lower fence, we're going to have Q1 minus 1.5 times IQR. And then the upper fence will be a plus, Q3 plus. So the upper fence is going to equal to Q3 plus 1.5 times IQR. Okay, Q1 was 2.055. 2.055 minus 1.5 times IQR, which the IQR we said was 2.69. 2.69. This one, Q3, will be 4.745 plus 1.5 times IQR, which was 2.69. So let's see what these give us. 2.055 minus 1.5 times 2.69, 0.69, negative 1.98. And for upper fence, we've got 4.745 plus 1.5 times 2.69. Enter. And we got 8.78. Okay, so negative 1.98. Negative 1.98. Upper fence, 8.78. 8.78. Are there any outliers? Well, we check to see if any is above or below our fences here. Outliers are values less than lower fence or greater than upper fence. There's no negative values here, so there's none lower than the lower fence, but 8.78. Let's see if there's any that are greater than 8.78. Nope. So, no, all the values are between lower and upper fences. What are the outliers? B, there are no outliers. Okay, next question. Okay, so the data represents the age. Find 5-number summary. Construct a box plot. Comment on the shape of the distribution. Let's go ahead and put these numbers in our calculator. So I'll go to Stat, go to Edit. I'm going to up arrow, highlight L1, press clear, and then enter. And we got 52, enter, 48, enter, 46 and 43, 46, enter, 43, enter, 51 and 56, so 51, enter, 56, enter, 50 and 63, so 50, enter, 63, enter, 44 and 55, so 44, enter, 55, enter, 44 and 61, so 44, enter, 61, enter, and 51, enter, 67, enter, and 46, enter. Okay, so now I'm going to exit out, do second mode. I'm going to do my stat, right arrow to calc, choose one of our stats, and press enter. Again, assumes L1. Then I'll down arrow till I can't do it anymore. The bottom 5 numbers is our 5-number summary, starting with the min. So we're going to have 43, 46, 51, 56, and 67. Okay. Now the box plot. I'm going to press Y equals. And if you have anything on Y1, just clear it out. So you press the clear key. Now I'm going to do a second Y equals. I'm going to do enter on 1, plot 1. Now we want to select on. So I do enter on. I'm going to down arrow. And I want to choose the one that looks like a box plot, which is the 5th one. So I'm going to right arrow until my flashing cursor is on the box plot. Press enter. And it assumes L1, which that's fine. If yours doesn't say L1, down arrow to that and press second 1. And then we're going to choose, it depends upon your calculator. The best way is to do a second mode to exit out. And then choose zoom and up arrow until you find zoom stat. There it is. So number 9. Some calculators you can go directly. You can press zoom and choose zoom stat. Some of the newer TI-84s you have to exit out before you do that. And the one it looks like is this one right here, C. Now the distribution. It looks like all the data's over on the left, which means it's skewed right. But let me show you the pictures for that. Where's my distributions at? It's a good question. 3-5, I guess. Okay. See over this one here? See where it looks like all the data is over here? On the left side, so it's skewed right. This one, all the data looks like it's on the right side, so it's skewed left. So it's opposite what you think. If it's in the middle, it's symmetric. So that's why on this one here, this is the one I chose, I said that it was skewed right. So, and there is no other questions, so let me submit test, see if I failed. I missed one. Sun was in my eyes. Yeah, that was it. Let's see. How did I do this? Review test. Let's see what I did wrong. I thought I chose that one. Alex had a better year because of a higher Z-score. You answered Alex had a better year because, but they say it's Alice. Oh, I think this requires some knowledge of baseball. What does ERA mean? What is our ERA? Oh, that's embarrassing. Earned run average. To say you have 9. Had the lowest ERA with the ERA. Oh, so the lower Z score is better. Because the lower ERA is better. Okay. Obviously, I don't know baseball at all. But when you work this problem, keep that in mind. Even though Alice had a smaller z-score, smaller is better in this regard, I guess, because smaller ERA, earned run average, mean number of runs yielded per innings pitched. 1 year, Alex had the lowest ERA, so I'm assuming that meant a good thing. Okay, I guess the lower the ERA, the better. So when you work that problem, keep that in mind. That wasn't too bad of a mistake. I can live with that score on a test. I won't redo it. Anyway, hopefully this helps you with the review and helps you succeed on the chapter test.